Alright, so we have been discussing how to solve all different types of equations, and every equation that we have solved so far has had one solution. And keep in mind that a solution is the value for the variable that makes the equation true. Meaning, when we plug it in for that letter, it will be equal on both sides. Now, what I want to introduce to you today is that sometimes we have equations that don't work out as nice as that. So sometimes we have equations that do not have a solution, or maybe they have more than one solution. So, I rewrote the definition here, but it's good for you to write and to see it. So what I want to look at today is we have this set of numbers contain possible solutions to the following equations. Determine which of these numbers are solutions to each of the following equations. Now, we can plug this solution in and then plug this one in and see if it works. Or a separate, maybe a little bit easier way for us to do this is to go ahead and just solve it algebraically. So what I want to do, I'm going to actually work mine out over here. And I want you to keep in mind those steps that we've been discussing all week. So I'm going to work A here. I'm just going to rewrite it, 9x plus 5. When you're rewriting, it's really, really important that you are writing it correctly. So step 1 said distribute. Well, I do have a distributive property here. So I'm going to rewrite 9x plus 5. I haven't done anything with that yet. 4 times x is 4x. 4 times a positive 2 is a positive 8. And then I have my plus 5x. My second step that we've been discussing this week is like terms. And I have like terms because I have x's on the same side. So I have 9x plus 5 equals 4x plus 5x is 9x plus 8. Now I have variables on both sides, so we talked about we need to get them all on the same side and we need to move the smaller. Well, these happen to be equal, so it really doesn't matter which one we move. However, they are both positive, so to move, if I choose to move this one, I'm going to have to subtract 9x because it is a positive 9x. Now, here's where it gets a little bit like, 9x minus 9x, that's 0x, it goes away. So I have 5 equals, and I have 9x minus 9x, well, that's 0 also, so I'm left with 8. So I end up with 5 equals 8. Well, 5 never equals 8. They're two complete different values. So I'm going to show that these are not equal by putting a line through my equal sign. This is a not equal symbol. And what this means is this can never ever happen. It means that the left-hand side, there is no value for x we can put here, and then put here and here, and for these to be equal on both sides. This is an example of an equation with no solution. There are no numbers for x that will make both sides equal or true. Okay? Let's try B and see what happens. I have no distributive property. I have no collecting like terms. So I'm going to do this one. I have a little bit of space right here, and then I'll do C down here in the margin. So for B, I'm going to just write it again. And I'm going to jump to step 3, which is variables on both sides. Well, this 3x is smaller than 7x, so that's the one I want to move, and it's positive, so I'm going to subtract it. 7x's minus 3x's is 4x. I'm going to bring down my minus 10. Make sure you're bringing down the sign in front of the number is equal to 14. So now I can do step 4, which was the inverse of add subtract. I'm subtracting. The inverse, or the opposite, is plus or positive. 4x equals be careful here. I'm looking at a lot of people's papers that they're writing plus and then they end up subtracting for some reason. So this is not 4, this is 24. So I'm seeing you writing the steps correctly, but you need to make sure you do what you write. Inverse of multiply divide, I get x equals 6. So again, that means I can put 6 here. If I do that, I get 42 minus 10, which is 32. I can put 6 here, which is 18 plus 14, which is also 32. So it's equal on both sides. So this is an example of an equation with only one solution. And that's the equation type that we're used to. So let's look at C. So we've looked at no solution and we looked at one solution. C looks like we're going to have to do all of our steps. I'm going to move down here so you can see my work. Again, make sure that you're writing it correctly. So I'm going to write 3x minus 12. And you can do this in your journal, of course, if you feel like that's more space for you. Okay. Step 1. Distribute. I do have a distributive property. I'm going to go ahead and rewrite the left-hand side. I haven't done anything with that yet. 3 times x is 3x. 3 times 1 is positive 3. Again, bring down that minus for the minus 15. Collect like terms. I have no like terms over here. But I don't have any more x's, but I do have whole numbers, or integers, that are like terms. Regular numbers can go with regular numbers. So I've got 3x minus 12 equals 3x, and then I can put these together. Now I have a negative 15 or a minus 15 and a positive 3. The signs are different, so we're going to subtract, and I'm going to have more negatives, so a negative 12. Variables on both sides, so again, they're the same. It doesn't matter which one I move. I do need to subtract because they're both positive. And I get negative 12 equals negative 12. Or even if before I get to that step, I can look here and I can see that it is identical. Both sides are identical, as well as the solution that I got is identical. So what that means is I can put any value in for x, and it will always be true. So what I'm going to write over here, I'm going to go ahead and write my 3x minus 12 equals 3x minus 12. Negative 12 equals negative 12. And I'm going to make a note that these are identical. If it comes out to be identical, that means that there are infinite solutions. That means I can put any number I want. I can put 10 in for x, and it will be the same on both sides. I can put negative 150 in for x, and it will always be the same on both sides. So what I want you to do, it says here, an equation has no solution if there are no values that will make it true. It has infinite many solutions if there is an unlimited number of values that will make it true. So what I'd like you to do is I want you to look at Laura, Nia, and Leo. And I want you to, they've worked out the problem correctly. I'm promising you that. I want you to look here, here, and here at their solutions. And I want you to label which one of these has only one solution, which one of these has no solution, and which one of these has infinite many solutions. So you should have said that Laura has one solution because it only equals one value. Here, it's identical. You can even look at the step above it. If it's identical, then it has infinite solutions. Again, make a note. Both sides are identical. And I use that word identical because it starts with an I and so does infinite, so it helps you remember that. I'm not sure on what planet these people are living on, but on my planet, 6 is never equal to 17, so this is going to be no solution. So I'm hoping this new concept is making sense to you. If you turn the page, I have a couple more little practice pieces. I want to introduce another vocabulary word to you. Some equations are true for all values of the variable. This type of equation has all real numbers as solutions. And we have all real numbers means that it can be a fraction, a decimal, a percent, an integer, a whole number, whatever, and it will work. Now, all real numbers, you're going to see this a lot. There's a special math symbol for all real numbers. It is an R with a double line. So, all real numbers as solutions means that the equation has infinite many solutions. So this is another way to write. You can write the infinity sign, you can write the word infinite, or you can write all real numbers, meaning this represents all of the possible values. Other equations are false for all variables, values of the variable, and this is no solution. So what I would like you to do, I want you to solve both of these. We've done a lot of practice solving. You might be able to even decide what the answer is. If it's no solution or all real numbers. And this one I want you to do on your own, and then on the Google form you're going to put your answer. If we look at number 7, this is a little bit extra thinking. Student claims that the equation 2x plus 6 is equal to 4x plus 4 has no solutions because when you substitute 0 for x, the left side has a value of 6 and the right side has a value of 4. Well, that's true. If we said, if we put 0 in for x, we get 6 here. And if we put 0 in for x here, we get 4. And in this case, for x equals 0, it is not true. But does that mean that no other value will work? Does that mean that there is no solution? Well, we can go ahead and use our mathematical skills in our steps. We have a variable on both sides. We can move the smaller. And we can simply solve this algebraically and see, well, is there no solution? I'm going to come over here because I ran out of room. 6 minus 4 is 2. 2 equals 2x divided by 2. Well, x equals 1. So is the reasoning correct that there is no solution? Well, no. There is only one solution. So just because one value doesn't work doesn't mean another value won't work. What about this? This says, why does x plus 3 equals x plus 2 have no solution? Well, we can again algebraically prove, if I put my variables on one side, well, 3 equals 2. Well, does 3 ever equal 2? 3 never equals 2. They're two different values. So explaining why, we can mathematically show why that is true, because there are no numbers we can put in for x that both sides will be equal. For what value of a does the equation 3x plus 5 equals 8x plus 5 have infinite many solutions? And I want you to remember what we talked about. Infinite means they are identical on both sides. So what would I need to put for a for the right side to look like the left? Well, hopefully you'll tell me a needs to be 3. Then it would look the same. Consider nx minus 4 equals 6. What are the solutions if the value of n is 0? Okay, well, we can just plug that in. 0 times 0x's minus 4 equals 6. Well, what happens when we do this? I get negative